Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam IFM. Let S of t denote the price at time t of a stock that pays no dividends. The Black-Scholes framework applies. Consider a European call option with exercise price date t, where t is positive, and with exercise price S of 0 times e to the rt, where r is the continuously compounded risk-free interest rate. You are given that the current price of the stock is $100 and t is 10, and that for every t greater than 0, the variance of the natural logarithm of s of t is equal to 0.4t. Determine the price of the call option. And here's the solution. We note that 0.4t, which is the variance of the natural logarithm of s of t, it's also the variance of the natural logarithm of s of t minus the natural logarithm of 100, because natural logarithm of 100 is a constant. But that's equal to the variance of natural logarithm of s of t over s of 0, because s of 0 is 100. And so that's the variance of the continuous compounded rate of return over the period of time of length t in years, so that the variance over a year must be 0.4, and the annual standard deviation, so volatility, is the square root of 0.4. And now we use the Black-Scholes formula and note that the call price is given by the standard Black-Scholes formula. There are no dividends, so that's reasonably nice. And also the present value of the exercise price is just s of 0. So this becomes s of 0 times n of d1 minus s of 0 times n of d2. And d1 is calculated using the standard formula, but that just ends up being the natural logarithm of s of 0 over s of 0 plus 1/2 sigma squared t over sigma squared of t. Of course, the natural logarithm of 1 is 0, so this is 1/2 times 0.4 times 10 over square root of 0.4 times square root of 10. But the square root of 0.4 times square root of 10 is the same as the square root of 0.4 times 10, so the square root of 4, which is 2. So we really have here 0.4 times 10, which is 4, divided by 2 times 2, which is 4, so this is 1. d2 is d1 minus sigma square roots of t, so it's 1 minus square root of 0.4 times square root of 10, and that's negative 1. And n of d1 is n of 1, which is 0.8413, and n of d2 is n of negative 1, which is 1 minus n of 1, so 1 minus 0.8413. And therefore the call price is s of 0 times n of d1 minus s of 0 times n of d2, and that's equal to 100 times 0.8413 minus 100 times 1 minus 0.8413, and we calculate this relatively quickly to be 68.26, which is answer C. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Well, good luck in your studies and good luck on the test.